Before it became an artifact in a shed, the McCormick-Deering No. 8 was once the dividing line between two eras of farming. On one side stood manual labor, seasonal urgency, and the constant fear of weather destroying an entire harvest. On the other side began a system where timing, output, and scale were increasingly governed by machinery rather than human endurance. This binder sat directly in that transition. In earlier decades, the same fields required large crews working for days or even weeks under unstable weather conditions. Harvest timing dictated survival for many farms, and every delay carried financial risk. With the introduction of machines like the No. 8, that dependency began to shift. Work that once demanded intense human labor could now be completed through a combination of animal power and mechanical coordination. In daily operation, the machine did not eliminate difficulty. It replaced one form of labor with another, managing horses, adjusting mechanisms, clearing blockages, and maintaining constant mechanical rhythm in difficult field conditions. But even with these demands, the overall system became faster and more scalable than anything available before it. Even as more advanced tractors and combines eventually replaced binder systems, the influence of machines like the No. 8 remained embedded in agricultural development. It helped establish expectations for mechanical reliability, standardized harvesting processes, and large-scale field management. These principles carried forward into later generations of equipment. Standing in an old storage shed today, the No. 8 is no longer just an old machine. It is evidence of the exact moment agriculture stopped being purely manual and started becoming engineered at scale, reshaping how food production systems would evolve for the rest of the century. By the 1910s and 1920s, the size of grain operations had expanded far beyond what earlier harvesting systems were designed to handle. Horse-drawn binders and reapers were still common, but many of them struggled under the pressure of larger fields and tighter harvest schedules. Even reliable machines became inefficient when farms stretched across hundreds or sometimes thousands of acres. A farmer could own fertile land and still lose money simply because the crop could not be gathered quickly enough. Traditional harvesting equipment also demanded constant physical effort. Operators spent long days exposed to dust, vibration, and heat, while manually controlling cutting height, adjusting clogged mechanisms, or repairing broken drive components directly in the field. Most machines relied on complicated arrangements of chains, gears, and wooden platforms that wore down rapidly during heavy seasonal use. Transportation created another limitation. Grain harvesting was no longer a local process tied to nearby mills. Expanding rail networks connected farms to distant markets, increasing pressure to deliver larger harvests at higher speed. Farmers needed machines that could operate continuously with predictable output instead of depending entirely on temporary labor crews. The agricultural industry understood that mechanization was becoming unavoidable. Companies competing in the growing farm equipment market recognized the opportunity immediately. Among them, International Harvester began developing machines built specifically for this new industrial scale of farming. And one model would soon become especially important: the McCormick-Deering No. 8. The McCormick-Deering No. 8 emerged during a period when agricultural machinery was rapidly evolving from simple assistance tools into essential industrial equipment. International Harvester, already one of the dominant manufacturers in the farm machinery market, understood that farmers no longer wanted machines but merely reduced labor. They needed equipment capable of transforming the entire harvesting process. The No. 8 was introduced as part of a broader transition toward more durable and efficient harvesting systems. Although exact configurations varied depending on production year and regional specifications, the machine was designed primarily as a horse-drawn grain binder, intended for large-scale cereal crop harvesting. Wheat, oats, barley, and similar crops could be handled more efficiently compared to many earlier binders still operating across rural farms. What separated the number 8 from older equipment was not revolutionary technology in a modern sense. Its importance came from refinement. International Harvester focused heavily on reliability, serviceability, and field endurance. Farmers operating far from towns could not afford complicated breakdowns during harvest season. The machine needed to survive dust, uneven terrain, heat, and long operating hours with minimal downtime. The company also benefited from its enormous dealer and parts distribution network. Replacement components, maintenance knowledge, and repair support became major selling points. In many farming communities, purchasing a McCormick-Deering machine meant access to a larger industrial system rather than simply buying equipment. The number 8 arrived at exactly the moment agriculture was becoming mechanized at a national scale. At first glance, the McCormick-Deering number 8 did not look like a machine built for the future. Its large steel wheels, exposed gearing, narrow operator platform, and long cutting assembly appeared awkward even by the standards of its own era. Modern enclosed machinery did not yet exist, and nearly every working component remained visible from the outside. Dust collected on moving chains, grease-covered bearings, and vibrating metal parts operated only inches away from the driver. But this seemingly primitive appearance reflected a practical engineering philosophy. Farm machinery during the early 20th century had to function far from workshops or factories. Simplicity was often more valuable than elegance. The number 8 was constructed so farmers could repair many failures themselves, using basic tools available on the farm. The binder mechanism itself was especially important. After the cutting bar sliced through grain stalks, a system of canvases and mechanical packers gather the crop before tying bundles with twine. Timing inside this process had to remain extremely precise. If synchronization failed, grain could jam the machine or fall unevenly onto the field. Large wheels allowed the binder to move across rough terrain while also powering parts of the internal mechanism through ground-driven gearing. This meant many systems operated directly from wheel movement instead of requiring a separate engine. To some observers, the machine looked exposed and fragile. In reality, its rugged mechanical simplicity became one of the reasons it survived in demanding harvest conditions for so many years. The mechanical design of the McCormick-Deering number 8 was built around efficiency through motion rather than engine power. Unlike later self-propelled harvesters, the machine relied primarily on horses for movement, while its internal systems operated through ground-driven mechanisms connected to the wheels. Every meter traveled through the field activated a chain of synchronized mechanical actions. At the front of the machine, the cutter bar used reciprocating knife sections moving rapidly against stationary guards to slice grain stalks close to the ground. This technology already existed in earlier reapers, but International Harvester refined the balance and durability of the assembly to reduce vibration and mechanical wear during long harvesting days. After cutting, rotating reels guided the crop onto moving canvas conveyors. These canvases transferred the grain toward the binding system positioned on the side of the machine. Inside the binder mechanism, stalks were compressed into bundles and tied automatically using twine. The knotter assembly became one of the most critical components because even a small timing failure could interrupt harvesting operations completely. The number 8 also had limitations. Wet grain often caused clogging, especially during heavy morning dew or after rain. Uneven ground increased stress on wheels and drive chains, while constant dust accelerated wear on bearings and gears. Operators needed regular lubrication and maintenance throughout the season. Still, compared to manual harvesting or earlier binders, the machine represented a major leap in productivity, consistency, and field capacity during peak grain harvest periods. When the McCormick-Deering number 8 first entered active use on farms, reactions were mixed. Many farmers immediately recognized the potential advantage of faster harvesting, but others remained cautious. Agricultural equipment was expensive, and a failed machine purchase could damage a farm financially for years. Rural communities often trusted tools only after seeing them survive several real harvest seasons. Early demonstrations became extremely important. Dealers and company representatives traveled through farming regions, showing the binder operating directly in wheat fields. Farmers watched closely as the cutter bar moved through dense grain, and the binding system produced tight bundles in continuous motion. For many observers, the most impressive detail was not speed alone, but consistency. The machine could maintain relatively stable output for long periods without exhausting human workers. Some operators struggled during their first seasons. Binder timing required adjustment, horses needed careful control, and inexperienced crews occasionally overloaded the machine in heavy crops. Twine failures inside the knotter system were especially frustrating because even small interruptions could stop harvesting progress entirely. Yet, successful farms quickly demonstrated measurable advantages. Fewer laborers were required in the field, and harvest completion times dropped significantly compared to older manual systems. Large grain operations benefited the most, because the machine allowed farmers to manage wider acreage before weather conditions changed. As neighboring farms observed these results, skepticism slowly weakened. In many agricultural regions, the number 8 stopped being viewed as an experimental machine and began to look like an economic necessity for modern grain production. Real harvesting conditions revealed the true character of the McCormick-Deering No. 8. Promotional demonstrations could show clean wheat fields under perfect weather, but actual farm work was far less controlled. Operators faced mud, uneven terrain, broken stalks, heat, dust storms, and sudden rain that transformed entire harvest schedules within hours. During long days in the field, the machine rarely stopped moving. Teams of horses pulled the binder through grain from sunrise until fading evening light. Dust from dry crops covered every exposed mechanism. Bearings required constant lubrication. Chains stretched under heavy loads, and knife sections dulled after repeated contact with soil or stones hidden beneath the crop. Wet conditions created some of the machine's biggest challenges. Damp straw could wrap around moving parts or clog the canvases feeding grain toward the knotter assembly. Operators often carried basic tools directly on the machine because field repairs were expected rather than exceptional. Replacing broken guards, adjusting tension systems, or clearing compacted material became part of everyday harvesting work. Despite these harsh conditions, the No. 8 earned a reputation for endurance. Many farms operated the same binder for years with only moderate repairs and replacement parts. In isolated rural areas, durability mattered more than comfort or appearance. A machine that continued working during difficult harvest seasons became extremely valuable. The binder also changed labor organization on farms. Smaller crews could now harvest larger acreages, reducing dependence on seasonal workers and allowing families to manage expanding grain operations more efficiently. As agricultural production expanded across North America, machines like the McCormick-Deering No. 8 began moving from isolated farm purchases into a broader pattern of regional adoption. What once had been considered a significant investment for individual farms slowly turned into a standard piece of harvesting equipment in grain-producing areas. Dealers reported increasing demand as neighboring farmers observed each other's results during peak seasons. The spread of the No. 8 was closely tied to the structure of agricultural communities. In many rural regions, farming knowledge circulated through direct observation rather than formal instruction. When one farm demonstrated that a binder could reduce harvest time and labor requirements, surrounding operations often followed within a few seasons. This created a gradual but consistent wave of mechanization. Manufacturing scale also played a role. International Harvester was able to produce and distribute machines through an expanding industrial network, supplying parts and maintenance support to remote areas. This reduced one of the biggest risks associated with machinery adoption: long-term repair uncertainty. Farmers knew that if something broke, replacement components were likely available through established channels. Over time, the number 8 contributed to a structural shift in grain agriculture. Fields could be managed more predictably, harvest schedules became more controlled, and reliance on temporary labor decreased. While newer machines would eventually surpass it in efficiency, the number 8 helped normalize the idea that large-scale harvesting could be mechanized rather than manually organized. The broader impact of machines like the McCormick-Deering number 8 extended far beyond individual farms, and even beyond the agricultural equipment industry itself. As harvesting became faster and more predictable, grain output across entire regions began to stabilize. This stability had direct consequences for food supply chains, storage systems, and commodity trading networks that depended on consistent harvest volumes. In many agricultural economies, wheat and other cereal crops were not just local products, but part of international trade routes. Increased efficiency in harvesting meant that surplus production became more common, strengthening export capacity and influencing global grain prices. Even small improvements in field productivity, when multiplied across thousands of farms, produced measurable effects in national economies. The machine also contributed to the gradual industrialization of rural labor. Fewer workers were needed for seasonal harvesting, which shifted employment patterns in farming communities. Some labor moved toward machinery maintenance, transport, or seasonal industrial work in nearby towns. Agriculture began to rely more heavily on mechanical systems and less on temporary human labor cycles. At the same time, food production became less vulnerable to local labor shortages. A farm that previously risked losing part of its crop due to manpower limitations could now complete harvesting within tighter time windows. This reduced waste and improved the reliability of grain supply chains. In this way, the number 8 was not just a field machine, but part of a larger transformation in how food production systems were organized and scaled. When the McCormick-Deering number 8 is placed back into the quiet rhythm of a single farm, its true historical weight becomes easier to understand. On the surface, it is just a horse-drawn binder sitting near a barn. It's still slightly worn, its paint faded by seasons of sun and dust. But this machine once stood at the center of a critical transition in agricultural history, when manual harvesting methods were no longer enough to support expanding grain production. In earlier decades, the same fields required large crews working for days or even weeks under unstable weather conditions. Harvest timing dictated survival for many farms, and every delay carried financial risk. With the introduction of machines like the number 8, that dependency began to shift. Work that once demanded intense human labor could now be completed through a combination of animal power and mechanical coordination. Even as more advanced tractors and combines eventually replaced binder systems, the influence of machines like the number 8 remained embedded in agricultural development. It helped establish expectations for mechanical reliability, standardize harvesting processes, and large-scale field management. These principles carried forward into later generations of equipment. Standing in an old storage shed today, the number 8 represents more than outdated technology. It reflects a moment when agriculture crossed a threshold, moving from manual endurance to engineered productivity. The fields it once worked have changed, but the system it helped create continues to define modern food production.